Okay, so we're in section 8.5 where we're going to add and subtract rational expressions. So just like when you were adding and subtracting fractions, you first thing you had to do was make sure that you had a common denominator. And the only way that you could add or subtract is if those denominators were the same. Kind of like here where I have A over C plus B over C. You don't do anything with the denominator. You leave C alone, and all you do is just add your numerator. Same thing you do with fractions. It's the same thing we're going to do today. So first off, let's take a look at being able to add and subtract radical expressions with common denominators like we have here for both A and B. So again, like I said, we're going to leave the denominator alone, so it's going to be a 30x squared. We know that for sure. And we get to add the numerator. So, but when we're adding the numerator, we must only add like terms. So I'm going to go, I have 5x squared plus negative 4x squared. So combining those two together, I'm going to get x squared. Then there's nothing in common with 12x, so I'm just going to say a plus 12x. And I have nothing in common with my constant negative 19, so I'm just going to write it as a negative 19. So my simplified expression here, when I add those two rational expressions, will be x squared plus 12x minus 19 divided by 30x squared. So now for b, same thing. I'm going to leave my denominator alone because we have like terms. And now with subtraction, I'm going to go, let's take a look at, I have 3x cubed, and I have no common, no like terms here, so I have 3x cubed here. I'll have like terms here, but I have a negative 4x squared minus a negative 3x squared. So that'll leave me with a minus x squared. And then I don't have anything with my 5, but because it's a minus 5, I'm just going to go minus 5. And that is as simplified as I can do. So fairly simple when you have like terms, but it's when you have unlike terms where you have to be able to find the least common multiple. So we can find the least common denominator. So all we want to do is find the least common multiple here. What I can do is say, okay, I want to combine 6x cubed minus 24x. What I would like to do first is let's factor out anything that we can have in common. So I would have, I could take out a 6x here. And then that leaves me with x squared minus 4. So I would have what? Oh, I had to find least common multiple for these two expressions. I don't know what I was thinking. But anyway, so here, again, same thing. I'm going to put 6x. But now I have, this is a sum and difference pattern, so I can say this is x plus 2 times x minus 2. Then for here, I could take out an x, which then x squared actually. And then that leaves me with x squared plus 3x minus 10. And then I can go x squared. And then I think I could foil this, reverse foil this out. And I can get plus 5 and minus 2. So to find the least common multiple here, I look at the outside here. I have a 6x and I have an x squared. So the largest value with the coefficients is 6, and then I have the x, and then the largest degree happens to be 2. So, and I see that I have a combination of x minus 2 and x minus 2, so I only need to write that once. And I'll have an x plus 2 and an x plus 5. So my least common multiple here would be 6x squared times quantity 6, or times quantity x minus 2 times quantity x plus 2 times quantity x plus 5. Okay, so now they want us to find the least common multiple between x squared plus x minus 30 and x squared minus 12x plus 35. So again, I can use reverse FOIL here. So I got x and x, plus and minus, and I can get a 6 and a 5. Here I can go reverse FOIL. I got x and x. I got minus and minus, and that'll give me 5 and 7. So my least common multiple here is going to be, I got these in common, so I only have to write those once. And then I just fill in the rest. And that would be my least common multiple. Okay? So now that we figured out what the least common multiple is to find the least common denominator, here are the steps in order to solve adding and subtracting rational expressions. First thing we do is factor out each denominator and then to find the least common denominator. Rewrite that fraction, and then if we multiply any value into the denominator, we must do the same thing to the numerator. Add and subtract, and then simplify. So if I have 3 divided by 10x squared plus 2x divided by 5x squared minus 10x, what I need to do first is I need to find the least common multiple. So I can't do anything with this 10x squared, so I'm just going to leave it as is. And then I can factor out a 5x here. So that leaves me with x minus 2 in the inside here. So my least common multiple here would be 10, because that's the largest coefficient, and I could put x squared here and multiplied by x minus 2. So that's the least common multiple. So that means that I get to put that on both sides of my denominator. So I can write this as 10x squared times the quantity x minus 2 and 10x squared times the quantity x minus 2. So now what I've done is, to that left-hand side of my addition sign, I have added a x minus 2 to my denominator. So since I've put that x minus 2 in the denominator, I must do the exact same thing to the numerator. So I must multiply by an x minus 2 here, with additionally with the 3. And what I've multiplied additionally with my denominator on the right hand side of my addition sign is I've multiplied a 2x onto my denominator, so I must do the exact same thing to my numerator. So what I'm going to do now is I'll distribute here. So I got 3x minus 6 divided by x squared over x minus 2 plus what, 4x squared divided by 10x squared times 20x minus 2. So when I add these, I can go 4x squared plus 3x minus 6 all divided by 10x squared divided by x minus 2. And that is its simplest form, so we'll leave it at that. So for B, let's find the least common multiple. It's here. I'm going to factor out this side here. So if I go parentheses, parentheses, I go x and x. This will give me what? Minus 4 and a minus 3. Over here, I'm going to have parentheses, parentheses, x and x. I'm going to have plus 5 and minus 4. So now my least common multiple here is I got these two in common, so I just can write x minus 4 once, and then it's x minus 3 times quantity x plus 5. So that's going to be what I write in the bottom for my denominator. So I got fraction here, so I'm going to write in x minus 4, x minus 3, and x plus 5, x minus 4, x minus 3, and x plus 5. So for the left-hand side of my plus sign, what I've multiplied additionally to my denominator is a x plus 5. So if I did that to the denominator, I must do the same thing to my numerator. So I'm going to put in coincide. What did I do here? I multiplied by an x minus 3 in the denominator, so I'm going to do the exact same thing to my numerator. So right now I'm going to distribute. So I got 4x plus 20. And I'm just going to leave the numerator, so I'm going to go plus 9x minus 27. And I'll combine like terms, which will give me 13x minus 7, all divided by x minus 4 times quantity x minus 3 times quantity x plus 5. So if I look at C, all I can do for that first denominator is I can factor out 3. So I can go 3 and x minus 5. And for the other denominator, I can use reverse FOIL. And then I'm going to get what? Plus 1 and minus 5. So my least common multiple is going to be, I got this the same and this the same. So I got 3 times x minus 5 times quantity x plus 1. So for the first one, let's write in 3 times x minus 5 x plus 1 minus 3 times x minus 5 over x plus 1. What I multiplied in that denominator on the left-hand side was an x plus 1, so I must do that to my numerator. And what I multiplied additionally to the right-hand side would be a 3. So I'm going to go 3 times 2x plus 2. So I'm going to distribute both my numerator. I'm just going to leave the denominator out. So I got x squared plus x minus, so let's put like a parentheses in here, 6x plus, what, 6? And so if I put in common factor, or like terms, I'm sorry, so if I go x squared and if I have x minus 6x, that's going to be giving you minus 5x. And I'm left with a negative 6. All divided by 3 times x minus 5 over x plus 1. And I'm not sure if I can factor the top out, so if I go parentheses, parentheses, to x and x, plus and minus, I have, would be 6 here, 1 here, and then I have 3 over x minus 5 and x plus 1. I can cancel out these ones, so now I'm left with x minus 6 divided by 3 times x minus 5. Okay. For D, I can't do anything to the x minus 3, so I just leave it the same. So I can reverse FOIL the second one and go x and x, minus and minus, 6 and 3. So my least common multiple will be x minus 6 times quantity x minus 3, since these are the same. So additionally, what I've put to the denominator of the first one would be the x minus 6. So I'm going to do that the same to my numerator. Minus, and I didn't change anything with my second one, so I'm just going to leave it as is. And I can FOIL this out, so I can go x squared, and I think at the end of the day it'll be minus 3x minus 18, all of which is minus x squared. And these will cancel out, so now I'm left with negative 3x minus 18, all divided by x minus 6, and x minus 5. But as I look at this, I think I can factor out a negative 3 here. So I can go negative 3, and then it's x minus 6. And I have, that should be a plus actually. And then I got what, x minus 6, x minus 5, I guess I couldn't factor, so I guess this is all I can do. Okay. So next off is being able to find complex fractions. Be able to simplify them at least. First thing you need to do is find the least common denominator, and then multiply the top and the bottom by the LCD. Cancel the denominators and simplify. Well, I'll give you that way. I'll give you two. I have two examples, and I'll show you two ways that you can solve this. First way, I'll do it the way that we had here in the little steps box. First thing they want you to do is find the LCD. So what I can do here is my denominators are x plus 5, x minus 3, and x plus 5. So my least common denominator would be x plus 5 and x minus 3. So what they ask you to do is multiply the top and the bottom by the LCD. So I'm going to go 3 over x plus 5 times it by x plus 5 over x minus 3, all divided by 2 plus 2 over x minus 3 plus 1 over x plus 5, all of which is multiplied by x minus 3 over x plus 5. So if I look at the numerator here, these will cancel. So now I'm just left with 3 times x minus 3. So now with 2 over x minus 3, I can cancel out the x minus 3, so that's going to be divided by 2 over x plus 5 plus, and I can cancel out the x plus 5 over here with the 1, so that leaves me with just x minus 3. So what I'm going to do now is I'm going to distribute the values. So I'm going to go, 3x minus 9 divided by 2x plus 10 plus x minus 3. And I can combine like terms, which then will give me 3x minus 9, all divided by 3x plus 7. Okay, so that's one way to solve it. Another way to solve it is to find the common denominator in each individual fraction, and then once you find it, like here's one rational expression, here's another rational expression, find the common denominator individually, and then divide them out, and then use what we learned when we divided rational expressions and multiply it by the reciprocal. So what I'm going to do is all I'm going to pay attention to is 6 divided by x minus 5 plus 1 over x. So what I'm going to do here is I can do x over x minus 5 plus x over x minus 5. Here I added an x, so I can go 6x. Here I can go just x minus 5. So adding these together, I'm left with 7x minus 5 over x minus 5. So that's the numerator in this. If I look at the denominator here, I can do same thing with the x minus 5. So the x over x minus 5 minus x over x minus 5, and so it would be 3 x minus 5, and then this would be minus 2x. I'd go 3x minus 15 minus 2x, common denominator, so now it's going to be x minus 15 all divided by x times x minus 5. So here, I'm going to say 7x minus 5 divided by x minus 15 over, I got too many ones, divided by x over x minus 5. But when we know that, we can, when we divide by fractions, we multiply by its reciprocal, so we leave this the same. We multiply it by x over x minus 5, divided by x minus 15. These cancel. So now we're left with 7x minus 5 over x minus 15. And that is being able to add and subtract rational expressions. Hope this helps. Till next time.